Is this mic on? Hey everyone, my name is Alex Volkov. I'm an AI evangelist with Weights and Biases, and this is ThursdAI Special Deep Dive. On this deep dive, I had the pleasure to interview Maxime LaBonne. Maxime is a senior machine learning scientist with JP Morgan. He is an author of a book called Hands-on GNNs, and you can buy that book on Amazon. He is an author in his own ML blog, which has a bunch of deep information. He's the creator of Lazy Merge Kit, which we talk about in the pod. And he holds a PhD in AI from the Institut Polytechnique de Paris, which is possibly the reason for the recent explosion in AI coming from Paris. Maxime has been mentioned on ThursdAI multiple times before. From his fine-tune of OpenHermes on top of neural chat called Neural Hermes to Neural Beagle, which is his latest work that topped the OpenLLM leaderboard in the 7 billion parameter category for a while. And I think it's still up there. Maxime also was the author of Fixtral, which we've talked about before, which was the first mixture of experts built on top of the Phi model from Microsoft. And in today's pod, Maxime goes into a new and exciting field in open source LLMs, which is called model merging. This is how I found Maxime, specifically because Neural Beagle is a merge of multiple other models, and we wanted to do a deep dive on what merging is. If you remember the previous deep dive with John Durbin, John released the Bagel models as a good merge base, and Maxime has authored Lazy Merge Kit, which is in charge of more than 50% of the merged models on Hugging Face leaderboard. And I really wanted to get to the bottom of what merging is and how it works. And this was a great conversation that I learned a lot from. I want to invite you to listen to the rest of this conversation, but also to make sure that you're invited to check out the newsletter, where the show notes and all links to everything Maxime does, and it's quite a lot, are there, including other commentary and images, which don't really show up well on a audio podcast. And if you work at a company that can sponsor folks, Maxime is open for sponsorship, and I think the community will benefit from folks like Maxime who have a lot of ideas, a lot of power and potential to build things, as long as they don't have to pay for GPUs out of pocket. With that, I give you Maxime LaBonne. Thank you so much for joining us, Maxime. The way that I came across your profile, you're releasing great content, specifically in the area of open source LLMs. And I've been seeing both the models that you release, but also some of the recent exciting stuff that we're going to talk about here about merging. This is my introduction. Feel free, please, to say how you would introduce yourself to the audience that doesn't know you and where you're from.
Thank you for the invite, and thanks for the introduction. I'm currently based in London, but I come from Paris. So if anyone is in London, always happy to grab a coffee together.
Awesome. Maxime, the reason why I asked you to join us is because, like we mentioned before, the merging of models is like this kind of fairly new thing that now is taking quite a lot of interest, enough such that like people are exploring this. And on top of the leaderboard in Hugging Face, the open source LLM leaderboard, a lot of the models, at least a huge amount of models, suddenly are merges. And could you give us like a brief intro, and we'll add the article that you wrote for Hugging Face to the show notes, but give us a brief intro, like what model merging is and how we should think about this for folks who are not super familiar. Just a brief.
Yeah, very simply, model merging is a technique to combine two or more LLMs into a single model. You have different merging methods within this model merging thing. And a good way to think about it, I think, is to think about it as a fourth step in the LLM pipeline. So you have pre-training, supervised fine-tuning, RLHF, and now we have this crazy combination of models called model merging, and where you can also find a mixture of experts.
So we'll get to mixture of experts, definitely. The one thing that I heard some folks get excited about is that we'll finally get to the bottom of how do we even call these models, because I know some folks here on stage call them Frankensteining models. Some Frank MOE was called. What's where you are in terms of like how we call these new, like Frankenstein always comes from just like taking different pieces and putting a model together. What's your current naming for all these things?
Yeah, I think that the Franken models, like the Franken merges, they are really one of these merging methods called pass-through. I wouldn't call your Beagle 14, for example, a Franken merge because it's using another merging algorithm. But yeah, it's quite creative in terms of naming convention at the moment.
And we did mention MOE. We're gonna get to fixtural first soon, but please, I wanted, so first of all, in the early start of the space, we also mentioned Neural Beagle, and I wanted to hear from you what kind of inspired you to work on Neural Beagle and what the merging work entails. So we have some idea. We had like fine tuning folks before. We have some idea about pre-training and supervised fine tuning. How does merge happen actually? Could you talk through this? Is that easy? Is that hard? Do you need GPUs? Do you need specific hardware? Do you need data sets, or none of that?
Yeah, I would say that it's very easy. That's why it's so popular. The reason behind it is MergeKit, thanks to Charles Goddard. It's an amazing library that really automates the entire process. So this is the main reason why this is so popular, right? Because you don't need a GPU, you don't need a big computer, you can do it pretty much everywhere. And it works really well. It works surprisingly well. You can basically pick two of the best performing models on the leaderboard and decide to merge them. It's probably going to work. And worst case scenario, you can always make a few attempts. So yeah, I think this is why it's so popular. I started really reading about it and playing with it in December. I've made a few attempts and I tried to improve on them, try to understand, get a good intuition of how it works. And I decided to summarize this work in an article about model merging.
Yeah, absolutely. And we'll have this article up for folks in show notes. Thank you, first of all, so much for breaking this down. Oftentimes, a technique like this happens somewhere in the GitHub area or comments on local llama in the subreddit and doesn't actually get explained. So definitely really strong thank you from the community about breaking this down and explaining this. Could you talk a little bit about the merge algorithms? There's different techniques. It's interesting where are those the new hyperparameters? Like are the merging kind of combinations of sorts, which models you use and which merging techniques are they coming up as the new hyperparameters of this area, specifically because this doesn't require hardware? How to think about how to choose an algorithm? What's your intuition there? What's the best one? And could you talk about the algorithms for now?
Yeah, sure. So there are different algorithms, as you said, and they're based on task arithmetic. So they're based on this idea that you have task vectors in your LLMs, and you can try to combine them to add a new task and add new capabilities to your LLM by just adding these weights. So based on that, people started becoming quite creative. The most obvious way of combining the weights of this model, the parameters, is to do some kind of averaging. So linear interpolation, where you can control, like, I want 70% of this model and 30% of this model. Linear interpolation, or however, it's not the best method. So people started using spherical linear interpolation. Not going to delve too deep into the details, but it preserves some geometric properties. So it works better experimentally, basically. That's why it's so popular. And then you have other techniques that are a bit more advanced, like ties and dare and pass-through. Ties and dare, I would recommend it if you want to merge more than two models together. Pass-through is to create like these Franken merges where you suddenly have a model with 9 billion parameters instead of 7, because you're going to replicate some layers from one model on top of the other. And for really traditional model merging, I would say. The slurp technique is the most efficient one. It's very good, but it can only merge two models at a time. But it works very well, and this is the method that I use for your Beagle 14.
So Slurp is, I keep seeing Slurp on the top of the leaderboards in Hugging Face, just in the name. So that's one easy way to identify whether a model was merged, like a result of a merge, or a different technique like a fine tune. I just really quickly want to shout out Pratik Yadav, a friend of the pod. He's been on the pod before. He's the author of the paper together with Derek and Leshem and some other folks on the ties merging model. This was in, I think, a June paper and last revised in October. So merging has been around before for quite a while. Maxime, how do you attribute the last, I don't know, a few months excitement about merging techniques? Would you attribute this to the merge kit specifically in charges, or some other reason why this now is blowing up?
Yeah, definitely. I would completely attribute it to MergeKit because, as you said, these techniques already existed a few months ago, but it was difficult to implement them. I remember seeing a bunch of scripts online and I wanted to try them for a while, but I was never motivated enough to do it. And I think that MergeKit really lowered the bar and allowed everyone to replicate a good configuration and make a lot of models. And then other people saw that merge models were performing very well on the OpenLLM leaderboard. So it could decipher where we are right now. And yeah, merges are really popular on Hugging Face at the moment.
Yes, like we said before, so much so that they've introduced like a little checkbox there that says if you want to filter out the merged models. I do want to like circle back a little bit on the Franken merge. Like you said, there is a way using these techniques to create like novel sizes as well. So we've been, actually, I don't know the reason why, but we've been in the area of there's a 3 or so billion parameters model. 7B seems to be like a sweet spot for many folks in models. And then 13B afterwards, and like around 30 and 70. Those were like the average, like standard sizes, or like the most common one. And we saw like Solar 10.7B was released, and I think it used something similar. They call depth upscaling, but it was essentially a merge of different techniques. And now we're seeing like novel sizes as well. Why? Can you say like why not stick around the same sizes? Like what's new about these different things? Could you talk about like how we're seeing like models all over, specifically because also on the LLM leaderboard, the checkboxes now don't make sense necessarily, right? They changed it from 7 billion parameters only to like around 7 or 7-ish.
Yeah, I don't really know why. I think that this model just perform better in terms of Solar. I think that the idea here is very similar to the pass-through. So these Franken merges, I don't even know the difference, to be honest with you. And it just proved to be very efficient and very powerful. So I guess that's why they're so popular right now. I guess the additional parameters really help the model. But why? Honestly, I have no idea why. I think more parameters is always good, but in this case, I cannot really understand why they perform so well.
Maybe for folks who are not on Twitter as many of us, I think, Nistan, you had a great reaction to somebody asking like why these models work, and it does not seem like there's a good intuition about why from anyone. It works, and I love the answer. Like this is basically Alchemy. We're throwing some stuff at the wall. So Maxime, it seems like you're also agreeing with us. This is where we're currently at. That's what we feel like. No idea why without additional pre-training, but adding more parameters, even from the same model, correct? So we can take the same like Mistral and make it double the size and will perform better without any pre-training. Is that like the gut feeling we're getting?
Yeah, absolutely. This is quite strange. I think there are probably some details in the paper from Solar, but it's not. I don't have a good intuition about these Franken merges. I have a better intuition about why the other techniques work. But right now, as you said, it's very experimental, and it's also challenging for the leaderboards and for the benchmark suites because they're not really maybe adapted to that. And it feels like the models that are merged are quite overrated on these benchmarks. So I'd say that currently my intuition is that merges work very well, but not as well as the leaderboards pretend. And that's why there's also a lot of people that are skeptical about these models. And I was also very skeptical when I started. But by comparing the results on different benchmarks, I can say that no, actually they work, right? They improve the performance. We don't exactly know why, but it's working.
Listen, go
We
ahead.
do actually have some pretty good intuitions. First of all, I think most people disagreed on the way the solar paper had put it. It seemed like they had no idea about that. Yeah, so these models in every weight, you have, if you look at how what's going on inside a weight, it starts to look like the whole Conway game of life thing. And I made a joke a while ago that essentially with large language models, it's like you're talking to yogurt. You have all of these little cells that you put together and stuff. But yeah, overall, the idea is that it needs a couple of layers for it to first process the embedding. And then there are certain layers within the model that do a lot more processing than other layers. And if you repeat those layers more often, the model gets to digest the prompt better and you end up with a better results. So we do have a pretty good idea. We just don't have enough data to write a paper on it and stuff. Unless Pharrell wants to, or LDJ wants to say more on it.
Yeah, it's both a question and maybe like a fact for these models is, even if you do, so Maxime, I'd like to know from your perspective on your models that you've released, but it seems that also you do want to train these Franken-merges afterwards, right? If the layers connect back and realign back to one another, because it's a traumatic experience to butcher together layers from different models that haven't seen each other previously. Maybe you can speak more towards that.
Yeah, that's what I was thinking about when I said we don't know how it works. It's really about without even any fine tuning, they can work better, right? And that I really do not understand, because if you add more parameters and they're properly initialized and then you can fine tune them, like it makes sense. But if they're not even fine tuned, like this blows my mind. I haven't been very successful with Franken-merges by myself, to be honest. So I'm not the expert on this topic at all, but they're very interesting. And I think that we're going to see more and more of them, because there are probably a lot of different ways of combining them. And yeah, we need more data to see what sticks, basically.
I think some of the Cobalt guys have a model that they've stacked 4 or 5 times with the Franken-merge, so it's become very large. I haven't talked to them to confirm that, but that is what I guess I've just heard in the grapevine. They're definitely a lot more brittle. I think is the key is making sure that you're not replicating input layers or output layers over both models. You want to definitely have one of each of those, so if the model's embedding layers interfering with itself.
By the way, if anybody's got a stack of 8 H100s just laying around idle, I do have a 59B Franken-merge on my Hugging Face, just waiting to be benchmarked. Yeah. Anyway, we'll just leave it at that.
I think Umesh, you had a follow-up question as well for Maxime.
Yeah. First of all, Maxime, you have one of the best blogs, so to say. So people who have not seen your blog should check it out. And also, pretty fan of your book on GNN. Really liked it. I just wanted to jump into a couple of questions that I had, specifically on the merging of the models. Like, if you were in this space earlier, we were talking about sparsifying the models. Have you tried sparsifying the models for a specific task and then merging those models to build an expert model that is expert in multiple tasks, basically? And if yes, then what has been your experience? Have you been successful? And second question I had was on the kind of benchmark. So I've seen on your collab book that you're using AutoEval, but are you using any other evaluation benchmarks to understand whether your merging has been successful or not?
Thank you. I want to also mention Charles Goddard's blog, so you can find it on GitHub. If you look at MergeKit, he has excellent articles about model merging. For your first question, I haven't really tried this kind of techniques. The only one that I've tried is laser, so layer selective rank reduction, thanks to Eric Hartford and Fernando. Sorry, I don't remember his name, but it's called laser RMT. And it's a really cool project to basically reduce the rank of some layers. And this is close to this idea. So right now it's a bit experimental, but apparently it works. Like from qual feedback, it works. I've tried that, but I haven't tried merging these kind of models. I think it can be very interesting because maybe they can retain their task a lot more than the traditional models that we use. To answer your second question, yes. So I made this wrapper to be able to automate the evaluation process because I was spending too much time doing that. But otherwise, I contact a lot of people who run benchmarks like EQbench, for example, and they're kind enough to run my models when they have time. And then they send me the results, and that allows me to compare the results of these models on different benchmark. Because at the beginning I was pretty sure that the models were crap, and they reassured me and they told me like, no, actually, like they perform very well on our benchmark too. So now I'm quite confident in these figures.
Awesome, Maxime. Just before we get to fixed role and your attempts at also MOE and how this ties into MergeKit, I want to talk about Lazy MergeKit. Is that a product that you released on top of MergeKit? Could you talk to us a bit about that, what it adds? And I think I saw a stat from you that more than like 50% of the merges uses your code with Lazy MergeKit. Is that correct?
Yeah, absolutely. So it's a very thin wrapper once again on top of MergeKit, and that allows me to quickly iterate over the merges. It's really good if you want to make a lot of experiments. I created 100 merges just to get a good intuition and then can evaluate them with auto eval. So I created my own little pipeline to do that. And yes, it became really popular, maybe thanks to the blog post where I also promoted. And now I checked today, actually, it was like 58% of the merges.
That's crazy. So definitely making a contribution to the community, folks. We will add the Lazy MergeKit and all the links to Maxime's blog, very in-depth blog as well, to the show notes. Let's move to MOE and how it relates to merges. So you released, I think, the first mixture of experts based on Phi model. We've talked about Phi before. For folks who are not familiar, a model that was released from Microsoft, trained on a bunch of synthetic data. Version 2 was recently changed, the license to MIT license. And Maxime, what prompted you to take this and make this an MOE, a mixture of experts, and how did you actually do it?
I really like these small models, and Phi 2 looked really good. The problem was the license. I was not very interested in the previous license they had. But they didn't change it, and I thought, yeah, now I have some experience using MergeKit once again to create MOEs. Why not trying to apply it to Phi 2? So the main challenge here is that the architecture is slightly different. So you have to really change the code in order to make something compatible. It's really made only for Mistral and Llama models. So I had to change a bunch of stuff, mostly the name of the layers and also different things to make it compatible, basically. And then I waited for more than a week because I didn't know how to change the inference code. So I had a model, but I could not run it, and that was very disappointing. At some point, I talked about it, and someone contacted me and said, yeah, I can do that. And he really helped me to do this. And that's why we managed to evaluate it and realize that it was performing better than the individual models, the individual experts. So I think it was very nice, and I decided to publish it based on these results. The person who helped me is Vincent Nguyen.
Incredible. So you released two models based on this, and like a 2x2 and 4x2. Is that correct?
Yeah.
You evaluated them compared to the base model itself. Have you done evaluations like for bigger models? Because Phi obviously is like very comfortable, but like number of parameters not that big. Have you done evaluations comparatively to like the big other models? Could you speak to its performance? Have you run this? Are you running this? Are you using this? That's, I think, also an interesting question.
Yeah, I run all these benchmarks. So I created on my Hugging Face account a little leaderboard where I store all my evaluations. And you can see it if you look at my profile. It's called Yet Another LLM Leaderboard. It's using News Research Benchmark Suite. And you can see that it performs well, but definitely not at a Mistral level. I also want to say that, yeah, like it performs better than the original model, and I find it pretty cool, but it's not like that much better either, right? And I think that's especially for the model with 4 experts, we need a better initialization of the gating weights, because currently it's using the 2 same experts every time. I didn't know it when I released it, but yeah, that was quite disappointing. Since then, I've tried, and other people have tried to fine-tune them to have better gating weights, but we haven't been very successful, actually. I benchmarked some of them, and the results dropped. Yeah, a bit more work to do on that side.
I see. Definitely one of the best things that come out of coming to ThursdAI is the interacting with the community. Hopefully, folks, you're hearing Maxime and the additional areas of research and expertise that needed. And it's great to be able to, I honestly just like maybe taking a side step. The way I found about you, Maxime, and like the way you're describing it, you've talked about you had a model, but you couldn't run it. Somebody came in. I love this part of our community, like especially on X. GitHub seems to be like a cool area as well. There's now a Hugging Face area where we can also like chat and talk about some things as well. And I absolutely love this part of the open source where people just talk about, hey, I need help with this. And some other folks come up. And I think this collaboration is what makes open source great. And this is the reason why we love chatting about this and highlighting community folks like this. Maxime, let's talk about this YAL, yet another LLM leaderboard that you also have. So very prolific. So far, we've talked about 4 of your projects. I have no idea how you have the time to all this. Could you talk about like the inspiration for YAL and like how it actually runs and what happens there? What are the evaluations? Could you talk about this a little bit?
Yeah, sure. Like it started with neural Hermes, which is like an open Hermes 2.5 Mistral 7B model that I fine-tuned using GPU, and I published it on Twitter. But actually, I did not evaluate it, and it got some traction, and I started like panicking, thinking, oh no, like actually the model is bad. But then Technium ran the evaluation for me, and he realized that the model was performing better than the original one. And I said, yeah, I need to be able to do that too, right? Do not rely on other people to evaluate my model. So I started creating this little auto eval thing. And then I saw that I was starting to have a lot of results. So it was difficult for me to even read them. So I decided to say, hey, let's create my own leaderboard doing that. And that's what I have now. And I'm proud to say that it's probably the most comprehensive leaderboard in terms of Phi2 models, because you cannot find them on the OpenLLM leaderboard. There's not that many of them, but it's still better than nothing. So if you're interested in Phi2, you'll find some result there.
I remember Neural Hermes, and back then I think it was Intel that came up with that dataset, correct? Then you fine-tuned Open Hermes on top of it.
Yeah.
And that was
exactly.
like very well performing. And I think like still this neural data set is flying around the merges. It's really interesting. I would love to, especially because you have now the leaderboard. It's not only your models, right? I see like Shadow ML there, a bunch of your models. Neural Beagle, the one that we've talked about, is the top one currently in this specific YAL leaderboard, but everybody else. So what is like special about this? How do models end up here that are not on the OpenLLM leaderboard? Do people need to submit directly to you, or is it pulling directly from the repository? How do models show up here?
Those are my own evaluations. So when you use LLM Auto Eval, it's going to upload the results in a GitHub gist on your account, and then this leaderboard can read like all of your gists and that's the data to create the leaderboard. It's a bit of a bring your own leaderboard approach. You can clone this space. There are like 2 variables to modify. And if you use LLM Auto Eval, you can create your own leaderboard based on your own evaluations. And if you want me to evaluate one of your models, feel free to raise an issue on this page and ask me to do it. If it's not too expensive, I will do it.
That's incredible. So LLM Auto Eval is a GitHub project. Also Maxime's GitHub, definitely worth checking out. And like you said, open ticket if it's not too expensive. I'm hoping that the people who hear this are getting impressed with the work that you're doing. And we've seen some sponsorships come up of these conversations. Maybe if you're already getting sponsored, definitely feel free to shout out the sponsors. And if not, if you're seeking sponsorship, this would be a good place as well to announce that as well.
Yeah, and then I'm looking for sponsorship. Thank you very much. Yeah, I'd like to run these benchmarks and do some stuff like that. it's starting to cost some money. So yeah, definitely looking for a sponsor. Thank
All
you.
right. So sponsors who are hearing
We
this,
should chat.
yeah, definitely. Alignment Lab here. Definitely feel free. Now you guys are all in the group chat. So we've covered the fixed models. Just one thing that I wanted to ask. There was somebody said MergeKit has an MOE kind of specific branch, or is it like merged into the main one? So now it's easier to create a mixture of experts models with MergeKit. Is that correct?
Yeah, so there's like a mixed branch to do these merges, and you have a moe.md file that documents how you're supposed to do it. And if you do not want to care about that, you can use lazy merge kit and just select the mixed branch. It's very easy, and then you don't have to meddle with it at all. It's quite automated.
Incredible. A bunch of projects. Maxime, how, like a personal question, how do you find the time for all this?
I don't know, like in the evening and during the weekend, I don't sleep a lot, so that definitely helps.
During the weekends and don't sleep a lot. This seems to be a prevailing thing among the AI enthusiasts here in the space, and also definitely on X. Sleep takes a backseat towards progress, and I definitely feel that as well. Maxime, I want to leave you some space. You said you're looking for sponsorship, and definitely folks should reach out. How else can the community help? So we've talked about evaluating some of the models. You said that there's like a few techniques that you've tried and didn't necessarily pan out, or didn't have time, or like fine tuning and then merging, etc. Could you speak about how else the community can help, and maybe this will actually happen? Feel free. The stage is yours to invite help as much as possible. Where to go, what to do, what you're missing hands with, where you need some additional support.
Yeah, no, that would be amazing. I have a few projects that I think are pretty interesting to me. For example, there's like the chess LLM thing that I'm doing with Kosti, who's actually currently listening to NTD Spot. And it's the idea of training very small language models to play chess. We started creating a framework around it with a notebook to create the data set, a notebook to train your model, and a space where you can like bring your own chess LLM and compete on a leaderboard with an ELO score. I think it would be really nice to complete this project. Requires quite some work. Right now, there's a preview version, and you can play with it. It's on my Hugging Face account. Feel free to participate if you find it interesting. I think it could be a good way to introduce like beginners to the world of LLM and training models in a very easy way where they can understand what's going on. And yeah, that could be a cool project.
All right. So meanwhile, I will say that, Maxime, you have a book out, Hands-on Graph Neural Networks using Python. Is that correct? Folks definitely should check this out. And also, I personally love like the stuff that you release in terms of learning and teaching. I will definitely add this to the show notes for folks who want to follow up. Your GitHub is explosive, and I definitely am interested in adding y'all to my bookmarks where I check the models. It looks like the Beagle model that you just released is the top 7B there with the average score of 60. I think this is the only model there with the average score of 60. This averages the AGI eval and GPT-4 Truthful QA Big Bench. This is the News Research benchmark suite. Is that right? This is how News evaluates some of the models as well. So definitely worth checking out. I'm going to send it to that leaderboard. With that, Maxime, I just want to like shout out a huge appreciation from the community about everything you do. Not only do you do this, you also teach and you explain clearly. Really a huge thank you for that. Merging has been on top of mind for many of us, and it's great to have you here and explain the ins and outs. The lazy merge kit, it looks like it's been used by more than half of all the merges on the top of the leaderboards, including like your own as well. Thank you for coming to ThursdAI. You're always welcome to come if you have like new releases that you want to cover or new cool techniques. And it's great to have you as participant in our group DMs as well. So hopefully folks who are sponsoring people, great people in the community are hearing this. Shout out A16Z and their open source grant. Like it seems like we have another candidate for that. Maxime, thank you. Feel free to stick around with us and just like chime in on the different things.
So yeah, that's what I wanted to mention. Thank you.
Thank you so much, Maxime. And thank you, listeners of ThursdAI. I hope this episode taught you something new like it did me. And definitely give Maxime a follow on his socials, which will be in the show notes. And follow his work because it's very exciting. model merging is very exciting. Maxime keeps open sourcing new stuff like the auto eval framework, and he just came out with a Gradio interface to show a model's genealogy based on what merges led to the birth of this model and what datasets were used for it. And it's pretty cool. It also shows which of the datasets and the previous model merges have a commercial license versus a open source license. Very important work as well. So thank you, Maxime. Thank you, listeners, for tuning in for this, and see you in the next ThursdAI.